Hello and welcome back to Survey of Biology, Unit 12, Section 3, as we continue our discussion of the immune system. So if you remember from the first two sections, we talked about layers of the immune system that were non-specific. So we talked about the first line of defense, the skin, mucus, stomach acid, that would try to keep pathogens out. The second line of defense is what did the body do once a pathogen had got into the body. So we talked about things like the inflammatory response, the protein complement, and such. And what we're going to look now is we're going to continue the immune system, and now we're going to get to the specific, the third line of defense. So if we look at the diagram here of the immune system, what we can see is that immunity has innate immunity that we've talked about. It also has adaptive immunity. And so there's natural adaptive, so there's passive, that's things that you might get from your mother through breast milk. Or there's natural active. So if you get the flu or have had chicken pox, you develop antibodies against that, and that's natural active. You can also have artificial, so we can talk about things like vaccines and stuff. But what we're going to really look at here is we're going to look at kind of the third line of defense and how that works in your body. So if you look at this diagram, you'll recognize many of these cells, especially over on the left. We talked about mast cells and how they produce histamine and they help with the inflammatory response. We talked about macrophages and how in the second line of defense they will eat up any type of pathogen that's not supposed to be there. We talked about the protein complement, natural killer cells, neutrophils. And there were some others on this diagram that we didn't talk about as much. What we're going to focus on now is the adaptive immunity. It's a slower response, but it's specific. So we're going to look at things called the B cell and the T cell. And these are blood cells that develop in the bone marrow. The B cells mature there. The T cells go to the thymus first. But those are the ones we're going to concentrate on our third line of defense. So the third line of defense, the big thing that we need to remember here is the third line of defense is specific. It is going to go after specific pathogens, whether it be viral, bacteria, or otherwise. And the third line of defense works with lymphocytes. So we're going to talk about B lymphos and T lymphos, or lymphocytes. And the key thing that these have that the first two lines of defense did not have is they have membrane-bound antigen receptors. And what that means is they have these receptors on the surface of their cell membrane that is going to bind to specific antigens. And so we can see here, there's a blue one here that will bind to a specific shaped antigen. It may have a different receptor, or a different cell may have a different receptor that binds to a different shaped receptor, like that. And then we may have a third type of cell. I'm showing them all on one cell, but they would usually be unique. A third type that would bind to a different antigen. Now, what are these antigens that I've been talking about? Well, an antigen is just an antibody generator. And it's a foreign molecule that elicits a specific response by lymphocytes. So this is anything that gets into your body that your body will mount a defense against. And so in some cases, it'll be a virus or a bacteria or something else, but it's something, foreign molecule, that elicits a specific response by the B cells and T cells. And this is what makes the third line of defense very different from the first two lines of defenses that we talked about. And with this, we're going to look at first at the B cells. And so what the B cells do is they carry out something called clonal selection. They clone themselves. So this is the selection of a lymphocyte with a specific antigen, and it activates the lymphocyte, stimulating it to divide and differentiate, so it kind of calls out the guard. And we're going to talk about two specific types of cells here. The first one, we have what are called effector cells, and these are also known as plasma cells. So these plasma cells are short-lived. They're produced, they do their job, and then they die, and their job is to produce antibodies. So the effector cells, the plasma cells, what they do is once they differentiate, they produce antibodies that are dumped into the bloodstream that are going to look for the pathogen and bind to it. In addition to the plasma cells, there are also memory cells made. These are kind of like the National Guard. These are long-lived. They stay in your body long after the pathogen is gone. And so if you have had the chicken pox as a youngster, if you're exposed to them a second time, your memory cells will be activated, produce antibodies, and that's why you don't get sick again. The same thing if you've had a specific strain of the flu. You have memory cells against that specific pathogen, so when you're exposed to it a second time, your body can respond much more quickly before you get sick. So you really need to remember that these two types of cells produced for this. There are the plasma cells, they produce the antibodies, and then there's the memory cells. And here's a diagram of what clonal selection looks like. So in your body, you may have many different, here's 1, 2, 3, 4, 5, 6 different types of B cells, and each one has a different type of receptor. So if you look on the surfaces here, each one of these is slightly different. And when you're exposed to a pathogen or an antigen up here, your body will find a B cell that matches. And once we get that B cell that's matched, that's what triggers clonal selection and leads to the division and differentiation of cells. So these B cells right here will divide. Some of them will become memory cells. And if you remember, these are the ones that are long-lived. They're going to kind of stay in reserve. They're always in the bloodstream, ready to be activated when needed. Some of them are going to become plasma cells. These are the short-lived ones, and their job is just to pump out as many antibodies as they can into your bloodstream. And so because the bloods and body fluids used to be called the humors, this is sometimes called the humoral or the antibody-mediated response. And so this is a direct result of B cell activation, the production and secretion of ABs, so antibodies into the bloodstream, and then the receptors of those cells, they're just transmembrane versions of the antibodies. So the antibodies over here kind of look like the letter Y. And they've got several different chains on them that we're not going to go into right now, but they recognize the antigen, and the receptors on the cells, they're just membrane-bound versions of the antibodies. They're very specific in looking for that type of membrane. So humoral or antibody-mediated response is dumping antibodies into the bloodstream, and they're trying to get the antigen or the pathogen before it can infect new cells, more cells. And so if we look right here, here's what happens with those antibodies. So here's an antibody right here. There's several of them kind of strung together. It looks like a star. And what happens is in the blood, they will recognize and bind to the antigen, to the pathogen. In this case, it's a bacteria with that specific protein presented on its cell membrane. Now, once it binds to it, it slows it down. It's a process called agglutination. They stick together. And so if you look over here on the right, here's an example now with a virus instead, but the antibodies stick to it, they slow it down, and what that allows the body to do is that virus is now slowed down and a macrophage can now come in. And remember, these are the big eater cells. They come in and they will gobble up the pathogen, antibodies and all, and dispose of it to help keep our body healthy. Now let's look at the response to the antigen. So this is why we don't get sick a second time around. So we're going to focus here on the blue line in this diagram. So if we look at this, here is our first exposure to antigen A. Someone sneezes on us by accident and we're exposed to the pathogen. Now there's kind of a period where it goes through, it starts to divide in our body, and for about a week, we may feel sick, and that's when we start to produce the antibodies. So we get a response, from 1 week to 3 weeks, 1 week to 2 weeks, right around here where the antibodies will peak. And we start to feel better, and the antibodies go down back to almost zero, but not zero, because the memory cells are there. Now, if we are exposed to antigen A a second time, right here at 28 days, look what happens. The response is much quicker and much stronger the second time around. So here is our secondary immune response because of those memory cells. So this is why we don't get sick the second time or third time or fourth time that we're exposed to the same pathogen. So this is how B cells work in humoral or antibody-mediated immunity to keep pathogens and antigens out of our bloodstream. And in the next one, we'll look at T cells and how that works. So thanks again for your time.